Okay, this is problem number 75 on page 62 in the textbook. It's from section 2.1. It says the number of living Americans who have had a cancer diagnosis has increased drastically since 1971. In part, this is due to more testing for cancer and better treatment for some cancers. In part, it is because the population is older and cancer is largely a disease of the elderly. The number of cancer survivors in millions between 1975, represented by the variable t equal to 0, and 25 years later, the year 2000, t equal to 25. And they've already come up for us with a function model of the relationship between these two variables. And the relationship appears to be quadratic. They probably did something very similar to a curve fit. And they collected the data from 1975 to 2000. So t will range from 0 to 25. That's a practical domain that pretty much they've got data in that domain for values of t and are pretty confident that this is a good model for that. Okay, part A. How many living Americans had a cancer diagnosis in 1975? So that's represented by t equals 0. And that's pretty easy. If I plug a 0 in for t in my function model, I just get 3.6. And 3.6 or 3.6 million, because it tells us that the function is calculating the number of people in millions. So a 3.6 represents 3.6 million. And also in the year 2000, where t is 25, I'm going to go ahead and put, oops, forgot a 0 there, put 25 in for t, and then I'll have to get my calculator and calculate this one, and that turns out to be 9.5 or 9.5 million people. Part B, assuming the trend continued, how many cancer survivors were there in 2005? They didn't collect data around the 2005 mark, so what they're saying is they don't necessarily know whether the trend would continue or this would still hold up as a good model, but if it did, then we would go ahead and go past the domain a little bit and let t be equal to 30. Again, we're going to have to get our calculator to calculate what this would be. And let's see, that turns out to be 11.2 or 11.2 million people. Okay, so in this problem they're giving us the functional relationship between time and the number of people, and then having us calculate or use this function to find out the number of people at various times. So that just means evaluating the function at t at various points.